Welcome to Session 3. Exponents and roots are inverse ideas. 5 squared means 5 times 5, which is 25. The square root of 25 asks which non-negative number squares to 25, so the answer is 5. A power builds a result by repeated multiplication. A square root works backward to recover the base. Seeing that relationship gives you a built-in check. If 5 squared is 25, then the square root of 25 must return 5. Today we will use that connection to handle negative signs, perfect squares, estimates, and applications. Read every power as a base plus an exponent. In 5 squared, 5 is the base and 2 is the exponent. The exponent tells how many copies of the base are multiplied, so 5 squared is 5 times 5, not 5 times 2. 2 cubed uses 3 copies of 2, giving 8. A square root reverses a square, while a cube root reverses a cube. The small symbol controls the entire operation. Before calculating, circle the base and notice whether a sign or group is included inside it. Parentheses decide whether a negative sign belongs to the base. In the quantity -3 squared, the whole -3 is the base. Multiplying -3 by -3 gives +9. In -3 squared without parentheses, the exponent applies to 3 only. 3 squared is 9, and the negative sign stays outside, producing -9. These expressions look similar but mean different things. When a negative value is raised to a power, ask one question first. Is the negative sign inside the base? Even and odd powers give another useful sign check. -2 squared has 2 negative factors. They pair to make +4. -2 cubed has 3 negative factors. The first pair makes +4, and 1 negative factor remains, so the result is -8. More generally, a negative base raised to an even whole number power is positive. A negative base raised to an odd whole number power is negative. This pattern lets you predict the sign before you multiply, which is especially helpful on a calculator. Square roots become easier when you know nearby perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, and the list continues. 6 squared is 36, 7 squared is 49, 8 squared is 64, and 9 squared is 81. So the square root of 81 is 9, not 40.5 and not 18. A square root is not divide by 2. It asks for the number that can be multiplied by itself to produce the value under the radical. Suppose we need to locate the square root of 50. Find the perfect squares on either side. 7 squared is 49, and 8 squared is 64. Because 50 lies between 49 and 64, its square root lies between 7 and 8. 50 is only 1 above 49, so the root should be just above 7. A calculator gives about 7.07, which fits our interval. This estimate is a powerful error check. Any display below 7 or above 8 cannot be correct. Exponents and roots appear naturally in geometry. A square has area equal to side squared. If the area is 196 square inches, write side squared equals 196. Undo the square with the square root. The side length is the square root of 196, which is 14 inches. Check by multiplying 14 by 14 to recover 196. Notice the units. Area uses square inches, while the recovered side is a linear measurement in inches. Use 4 questions to stay accurate. What is the base? Is the negative sign inside it? Is the power even or odd? Which inverse operation checks the result? Final challenge. Evaluate the quantity -2 cubed plus the square root of 81. The odd power gives -8. The square root is 9. -8 plus 9 equals 1. The answer is 1. Parentheses control the base, parity predicts the sign, and nearby perfect squares protect your estimate.